Welcome to the CAD Office Training Guide series for F.Connect. I am Todd Hood, CAD Applications Training Coordinator. Today we'll be going through the Roadway Design Existing Modeling Guide. In this series of videos, I will take you step by step through each exercise from the guide. Today we will start with Chapter 4 of the guide. This guide will go over the fundamentals of creating a 3D model for existing features to include hard surfaces such as asphalt, concrete, sidewalks, curb, utilities, drainage structures, and soil borings. Participants will be introduced to the Bentley Open Roads Designer Connect Edition Open Roads Technology Tools for design and modeling, specifically for FDOT projects, using the F.Connect workspace. Let's begin. Topics covered: creating existing utilities, MODLRD file, will reference the GDTM-RD or a SERVRD file. Use the Extract from Graphics tool, then we'll show existing utilities in a dynamic cross-section. Chapter 4, Existing Utilities Modeling. Introduction. These exercises will introduce a new ORD workflow, a menu that will be used to lay out existing utility lines. The Drainage and Utilities workflow in the Open Roads Designer will be used. Drainage and Utilities workflow. A SUDA and SU database will be introduced into the file. A new MODLRD file will be created. The optional modifier from the Create File tool will designate it as the file for existing utilities. Example: MODLRD _ existing utilities.dgn. Elements will be extracted from 2D elements and given features for 3D. This will be done in order to see existing utilities in the 3D model, and that can be seen in cross-section views. Exercise 4.1. Create the existing utilities model file. Open the underbar blank file.dgn for the current work set that was delivered, or any DGN file within the current work set, which is 220.495.55201 underbar CE. I'm in the blank file. I'll then navigate to the FDOT tab. Under the Actions group on the ribbon, I'll use the Create File tool. Clicking on that will bring up the Create File dialog. I'll make sure the discipline is roadway. The file group will be roadway design files. I'll click on the base file name with MODLRD. Verify that I have the MODLRD base file name. I'll key in the modifier that's optional, an underbar, capital EXISTING, utilities, capital UTLIITES. This will be the first file in the sequence. The modifier can be anything that you want to be more specific to what the base file name or what the file will be used for. I'll verify that the county is set. If not, I'll set the right county. It's Wakulla. That again will set the coordinate system. Once the dialog is set, I'll click on Create and Open File. That will create us an MODLRD underbar existing utilities.dgn. Once we get into the file, we'll verify we're in the MODLRD existing utilities.dgn. We'll close the Create File dialog. The first thing that we need to do is switch from the Open Roads Modeling workflow. So we'll click on that in the top left-hand corner. We'll switch to the Drainage and Utilities workflow. This will bring up a new ribbon tab with different layouts or workflow for the drainage and utilities. We'll click on the Layout tab. The first time that we get into a file, we're going to get a message. So if we click on the Place Nodes or any of the drainage and utilities tools from any of the layouts, we're going to get a message that the action will create a utility model in the design file. You cannot undo this action. Proceed. So let's click on the Place node. This is normal for the drainage and utilities workflow. So what it's doing, this message displays the first time when you are setting up a drainage or utilities file is normal. This file will become a utility model and it will attach the SUDA and SU database. This file will be different once this step is complete. It'll have more information. So we'll click Yes. That's setting up the file from Create File tool and getting the file ready to be a SUDA and SU database. Moving on to exercise 4.2. referencing the GDTM and or SERVRD. In exercise 4.2, referencing the GDTM and or SERVRD, we're going to open the reference dialog by using F9, or I can go back to the Home tab under the primary group and attach tools. Either way, that'll bring up the file, the reference dialog. So I'm going to click on the attached references, back up to the survey folder, double click on that. I'm going to attach the GDTM RD01 for the existing ground, and also the SERVRD. So holding the control key, I'll select both files and select open. The first file is going to be the GDTM RD file, so I'll give this a logical name of GDTM for my existing ground and click OK. The next file is going to be the SERVRD, so I'll give this a logical name of UTEX, and then once those are attached, I'll flip view. We now have two files attached. Exercise 4.3, using the Extract from Graphics tool. The first step is to set a level filter for the SERVRD file that we'll be using to just display the existing utilities. So I'll go to my level display. I'll click on the SERVRD file that has a logical name of UTEX. I'll come up to the levels and click on that split down button. I'm going to use filters. Our filter list, I'm going to pick the UTEX filter. So it's standards.utex. What this will do is set this survey reference with the logical name of UTX to only display the utilities in the file. Then I'll switch back from filters to levels. You'll see it turns everything off except for utility levels. And then I can zoom back into our project area, and we'll see now that we only have utilities shown. We have some overhead lines. We have a water type A, a non-potable water system type B line, and a sanitary sewer type B. Those are the lines that we'll be extracting, are these underground utilities in the next exercise. There's not too many of them, but we'll show you how the tool is working. Once we have that set, we'll go to the element selection tool. We're going to set our terrain, or the existing ground terrain, active, so we have a 3D model. So we'll click on the boundary for the existing terrain, which is the green dash line, or the level DTM-EX. I'll click Set as Active for a 3D model, now that we've introduced a 3D element into a 2D file. I'll go to my view controls by right-clicking and holding. I'll go to the view control. I'm going to set up two views, a plane and 3D. And then in the 3D view, there's going to be a little extra work, so we'll make that view active, which will be view 2. So I'm clicking on view 2, the default dash 3D, to make it active. In the view 2, the default dash 3D, we don't need all of the survey reference that is referenced that's shown. So we're going to turn that display off, completely off. Because we have the existing ground from the GDTM RD file. That's all we need in the 3D for right now, because we're going to be using the Extract from Graphics tool. And extract from these graphics will show up in our 3D. So the only thing that we need in the 3D view, or view 2, the default dash 3D, is the existing ground. So I'll go into view 2, make it active. I'll then bring up the level display and turn off in my level display for the SERVRD 01 file. Or I could do that by the reference dialog by clicking on the SERVRD reference. So once that's set, I'm going to fit view, and I'll zoom out view 1 because I have graphics out farther out than I need to. And then I'm going to save settings to save these two views. So I'll come up and do either Control F or the save settings. So from the drainage utilities workflow, we'll go to the layout tab. Then there's the layout group. We're going to use extract from graphics. That'll bring up the extract from graphics tool dialog. Now we'll set this up. So the method will be selection. Your use 3D element elevations, that will become active. That's an optional modifier if we're not going to use a existing ground or vertical offset. So we have two options which we'll go over. The design stage won't be set because there's no settings for that. But what we do need to set is the feature definition. So we'll zoom in the 2D or view one to show the sanitary sewer line. Or we'll do this group of lines right here. So let's first step water A. Let's work on the water A. So I'm going to set feature definition. You'll notice that it's going to be a conduit folder, and then within the conduit folder we'll see the different categories. We have communications, electrical, gas, stormwater, wastewater, water segment, and generic segments. So this is in the water segments for existing. We have two categories under that, non-potable, so we'll use that for this line, or a water line. And if you go off the tool to show you like I did, you'll have to come back. So we'll go back to the water segment, existing. We'll pick on a water main. And these levels have changed, so we only start with quality level B. So we'll select that. Feature definition. That'll give us a name prefix, and then a description is the size. So we'll leave that at 10 inches. And now we're ready to use the tool. So the first left-click data point is to set the method. So that left-click data point in space. Now it's telling us to locate the elements. So I'm going to locate all the elements that I want to extract. So I'll click on the water line. You may have to do it one or two. It'll tell you that the object is already in the current set. So I have this line, that entire line. Then I'll zoom up. There's more water lines over on this section. Okay, and a little tiny water line right here. And once you have everything selected for all your water lines, zoom out, zoom back in, just to verify and make sure I have all those lines. So I have this group of water lines and this group of water lines in there. They're all going to be existing water lines, main, the quality level B, and a description of 10 inches. So it's going to be a 10-inch water line, which we'll leave that for there. It may be 10 inches, it may not be. We can always change the size afterward, or we change the size before. So once we have everything located, we want to right-click to reset to complete. So I'll right-click. And now this is where the 3D element comes into play, which we won't be using for this exercise. But we could toggle this on. We don't have to put a vertical offset in here. So I'll show you two different ways to do it. So we're going to do a vertical offset for water lines of 2'6". So we'll go minus 2.5 will give us 30 inches. We're not going to use the 3D elements at this time. We will in a later exercise for drainage. So we'll just left click and data point through. It's asking us to select the surface or reset to use the active terrain. So we could reset because we have an active terrain because that's what's created our 3D model. Or we can select the surface. Then it's going to work through the vertical offset. So left click data point again. There's no trenching because these are existing. So if we needed to create trenches, we would just check that box on, which we don't for existing. So we'll left click data point. It'll extract these new levels and information from the graphics. And in the 3D view, you'll notice, if I zoom in there, we have our 3D feature. There's a profile line that it puts on here, but that's okay. We'll have to do a little cleanup later. So let's do that. Repeat those for the sanitary sewer and also the non-potable water. So let me switch the sanitary sewer. We'll say that's at minus 2 feet below the existing ground. So we'll go to, from the main water, go up to the wastewater segment, existing. This will be sanitary sewer, type B. Again, I'll left click data point to set the method. And now I'm able to locate elements. So I'll go through and start clicking on my 2D elements and get them in the selection set. So once I have all my elements selected, I'll right click to reset and then left click data point working through the tool. So again, we're not going to use the 3D elements. We'll select the surface, which is the existing ground, 2-foot offset, so we'll left click data point, no trenches, left click data point. It'll work through the tool and create links, and now that we have sanitary sewer. Let's do it one more time for our non-potable water. First, switch the feature definition, so we'll go back to the water segment, existing. This time we'll pick the non-potable water category. And again, it'll be level type B. Let's say that maybe this one is -3 feet below. Let's actually put 0 in there, and I'll show you that we can pick the 3D elements if we know if they are 3D elements. Usually they will be because they're coming from a servrd. So again, I'll left click data point, and it's asking to locate the elements. So that's going to be all the non-potable water. And now you see that the checkbox for use 3D element elevations is allowing me to put a checkbox in there. So I'm going to check that box and not put anything for the vertical. That way it'll use the 3D element as the actual elevations. So I don't have any more non-potable water, so I'll right click to reset. And you just left click data point working through the tool for the use 3D elevations. This time it says yes because there's a checkbox. Data point, left click data point, and left click data point. And you'll notice again that I have the elements in. It plotted that. You also notice in the 3D that it is pointing either caps or features on there on the default level. You would have to come back in and change these to nodes. So there's conduits, which are links, and nodes, which are the actual structures. So we would have to come back and fix the structure to put either a fire hydrant or a valve or something like that in there. And you can simply do that if you just click on, let's do it for the sanitary sewer. So in the 2D view, you would just go back to your element selection tool. We can go to the properties, so there's no feature definition set. We would just set the feature definition. And this will be explained a little bit more in the next chapter for drainage. So we go to our nodes, we come to, this is a wastewater node for existing sanitary sewer. This could be a sanitary sewer manhole or a valve or a clean out. We zoom back into our 3D. Here, I believe we're still working on that. Oh, that was it. So you'll see that that changed to a manhole in the feature definition. So you extract from graphics, and then you change your ends to be the correct nodes. So that's the extract from graphics tool from exercise 4.3. Moving on to exercise 4.4, show existing utilities in the dynamic cross section. So I will go back to one view. I can do that by holding the control key in F1. It'll take me back to a one view. To do this, we need an alignment to track off to create cross sections. So let's go back to the Home tab. I'm going to go to the primary group and bring up the reference dialog. So we can attach the alignment file to ALGNRD. Again, you can bring up the reference dialog by the function key F9. So I'm going to go ahead and click in bring up the attached reference tools. I'm going to attach the ALGNRD01. I'll give it a logical name of ALGN. The nesting depth will be set to 0 because I only want the elements in for the alignment elements. So now that we have that referenced in, we will set up our views again. So we can do that by right-clicking and holding. That'll bring up our right-click function for view control. So this time we want to find 3 views. We want 3 views plan XS, which is cross-section in 3D. So I'll select that. From the tool, it'll set those up. Open a dynamic cross-section view, select OK to create a dynamic cross-section. That's jumping right into the tool. So we need to select our alignment. We'll put a left offset and right offset. We'll select a station and then interval. So it's setting up the tool to set 25. And once we have all that set, it's asking us to select or open view. So we already have a view open. So we'll just select in that view. And you'll notice after we select that, we have in our cross-section view, we do have the existing graph and we have our existing utilities. So we can walk through that. That's setting it up right from the tool. So what if we need to redo a cross-section or redo a dynamic cross-section? We can still set up the views, which we have here. So if we need to do it again, we'll switch from the drainage utilities. We'll go back to the open roads modeling. And then we can always go to the corridors tab in the review group for dynamic cross sections. So there's 2 ways to do it. We would pick the dynamic cross section. This is asking us to locate a corridor or alignment. We don't have a corridor. So we're running this off the alignment. It then asks us to do a left offset. So we can type in -130 and then a right offset. And then data point to accept. And now a right offset. So we can do 130 to the right. And then tab and left click data point. In a station, this is just where it's going to start. So anywhere you want to start. And then the intervals is how far it's going to step through each cross-section that we have when we step. So we'll do 25, and again, it'll ask us to select or open a view. We have a view open already, so we can just select our data, left-click data point in that view. Gives us a new cross-section. So once we have that set up, you can right-click or just data point up in the cross-section navigation window. Or work your way back. We can also right click and hold and locate station via data point. So we can select the plan or profile view. We want to select our plan view. And now we can track off and go to a specific station if we want to in our off the alignment. So say it was 28.00.0. We'll just type that in, that'll take us right to that station. And then we can see what our dynamic cross-section or utilities are doing at that cross-section. We can center on backbone, which is the alignment, and walk through. So that'll walk through there. Here's our existing utility lines. We'll see that the one came a little bit bigger in there. So that is the Extract from Graphics tool, and that is chapter 4 of the guide, Existing Utilities Modeling. Thank you for joining me today for the CAD Office Training Guide series for FDOT Connect.